Okay, so this is the third class. We're gonna try recording. So we'll see how well this works. We'll create MP4s and put them on the website. They're not going to be terribly compressed, so it's going to probably be about almost a 3 gig file. I apologize, but yeah, it'll be about a 3 gig file. But you're going to be on the university network. It will download fairly quickly. So, it's fine. It's not going to be, right, and you probably only want like one at a time on your machine. So, fine. Yeah, it's not a problem. Okay, let's see. First of all, let's do administrative stuff. David said there were a few questions about the homework. Just sort of understand that the first homework is actually due, the first and second together are due on Friday midnight, just to make sure there's no confusion about that. Other questions about homework or class structure or anything along those lines? Okay, excellent. Let's see. We've made some updates to the website on the installs. How many people have, at this point, have installed? Hopefully, you've installed Git and Bash. You're gonna have a hard time doing the homework without it. Anybody having problems with installing Git and Bash? Okay, great. Anybody try to, how about Sublime, the text editor? Any problems there?
No.
No, okay, gotcha. Okay, so no problems there. How about Octave, MATLAB? Have you been able to get access there? You have many options there. There are a couple of online options. There's stuff you install on your machine. So no problems there. Anybody with a problem, let us know. Okay, has anybody tried to install Python yet? Okay, so a few. If you have a Mac, you already have Python there. And we specifically, the versions of Python matter. So a 2.6 or 2.7 is what we'll be using. It turns out that Python 3 actually has some very big differences from the 2.0 different versions. And so we're going to stick with 2.6 and 2.7. There's some, for right now, I won't go beyond that. There's a large piece of scientific Python scientific software called Anaconda. It brings in a whole bunch of packages, is what they're called, and we'd like you to install that as well. But let's get to Python first. You do deal with that. We've got many lectures before you get. We're doing Python, so you got some time. Okay. So today we're going to get into MATLAB. So this is going to be the first one we're talking more seriously about programming. How many people here have heard of MATLAB before? Okay, everybody. How many have done some MATLAB programming? Okay, just about everybody. Okay, wonderful. Okay, so this is the first one. This is really looking at it from the point of view of of what it is as a programming environment. So there are actually two programs we're going to be dealing with, and we're going to sort of treat them interchangeably. There's MATLAB and there's Octave. MATLAB is a program product that you have to buy from a company named MathWorks. Some departments actually have a license to use MATLAB, and feel free to do that. The other alternative is to use Octave, which is free. And there are a variety of ways of getting to both of these products. Okay, so hopefully we went through this about the install on there. The online version, you've gone through and you've looked at this. I assume this Coding Grounds one is one you've probably looked at, and the other possibility is the Sage Math Cloud. So this is available on the software tab. Well, the relevant information is available on the software tab of the course webpage. Okay, so we're going to talk about today, there's several things here. One of them is that I will give you sort of a walk through certain essentials of MATLAB. This is not a class, this is not a programming instruction vocational education class, this is a college course. So I'm expecting you to sort of fill in a lot of the blanks. I'm going to focus much more on concepts and a certain amount of details and some skills that you need to be able to program effectively. Probably one of the most important one is, where do you look for information? So getting help, you can get that from MATLAB itself and also or online. There's a variety of online sources. And then we'll go through, I don't know how many of you took a look at that article on 5 concepts in programming. But that's sort of the way I'm going to structure this. Not exactly along those lines, but it's really much more conceptual approach. And MATLAB is one example of this. And to program effectively, there's always more that you're learning. So, it's not like, it's a one-shot type of deal. We expect you're going to be doing a lot on your own. All right, so that MATLAB has a command called help. And if you type in help, then it will give you instructions about how to use help. And so typically you're talking about help, and then you put in the name of a command. I can, okay. Yeah, I won't. I mean, this would be a sort of a silly demo, so I'm not going to go through that. But we'll do that once the point we start doing a little bit more demos. I'll show you an example how to using it. Okay, so the first real content part here is the notion of data types and data structures. We've seen a bit of this before with spreadsheets. So you remember from the spreadsheet that we had a variety of structure. Or I guess yeah. Actually, we didn't show this spreadsheet. I showed another one before. But this is one that computes net present value. And if you look at the spreadsheet, what are the data types that you see in this spreadsheet? Remember, what would be an example? How about this one right here, 12.00? What's that? It's a floating point number. Okay. What about, how about the 0 right there? It's an integer, exactly. Okay, and then there are sometimes, like in the example we're looking at with the sequence translation, we'll have character too. So those are the main ones. The other thing that you could do, and we saw this you probably encountered this when you're doing your homework on the prime numbers, is there's Boolean. You test for a true/false, and these are really the basic data types. A lot of times there's a distinction made in some languages between data types and data structures. When we get to Python, there's actually no distinction made. I mean, it's sort of, data types tend to be built in, and data structures are things that you manufacture generally. I mean, it's not totally true. That's generally the distinction. But the idea is that there's certain basics that you're working with. So a floating point number, an integer, a string, and a Boolean. Those are the basics you tend to work with. And then you combine them together in various ways. All right. So we went through and did some answers here to what these various ones are. I mean, for example, what about this one right here? What's that? What data type is that? I'm sorry? So I heard two things, a double and a string. Which one is it? It's a string, right, it's in quotes. And this is actually a subtle point, and it's actually an important point. There's some languages that, I mean, for example, if I took this string and I divided it by 1, what would the answer be? Well, it could be a lot of different things, depending on the programming language. It might automatically convert that string to a double, or see if it could convert that string to a number. And if it did, then do the operation. Another thing it might do is call an error. Say, wait, you're dividing a string by a number. I don't know what that means. So recognizing almost all operations, this is probably one of the most common ways, most common errors or type of error you will encounter in programming is some sort of type inconsistency. These type inconsistencies are relatively easy. As you get into more complex data, and Python has objects and the data becomes quite complex, then the inconsistencies become much more involved. All right, so that's about types. So data structures are combinations of these basic types. So, the simplest one is a scalar. So if you look at this over here, and it's, sort of the way we're interpreting this is computing net present value over 4 years, the current year up through year 3. And so you can think of this, although a spreadsheet doesn't do this, as sort of a group together there for the years, 0, 1, 2, 3. And so that's an example of an array. And you've encountered this before, whereas interest rate is a single value, that's a scalar. And so typically you can have a variety of different kinds of structures like that. What would be an example in this spreadsheet of a 1x4 array of floats? You see something there, 1x4 array of floats? So if you look at, you're looking for something that has 4 values, and it has a decimal point. So it's sort of implied here. It's written as percents, but percents are really fractions. So this would be an example of a floating point array. So the other thing about this, which it becomes more important, especially as we get the details in MATLAB, is in MATLAB the primary data structure are matrices. So you have rows and you have columns. And that really determines, and then there's the values that are inside. What are the types? Is it a string? Is it a float? Is it integer? Is it a bool? Those are going to be your choices. So whether it's 1 by 4 or 4 by 1 actually makes a difference. I mean, you know this from matrix multiplication. You know, multiplying by 1 by 4 array is different than a 4 by 1. So these are actually, and the row comes first and then the column. So this would be a 1 by 4. Whereas, you know, I don't know what this would be, but if we had something like that, that would be, you know, that'd be 5 by 1 down there. Okay, so the kind of data structures you have, you know, as I said before, they're matrices. Vectors are just a sort of a simplified matrix. And the examples I have here all use octave, but this should work. We've done our best to try and make this consistent with MATLAB as well. If you find inconsistencies, let me know. So you can, let's actually at this point, let's to actually using the program. Okay. All right, so there are various different variations on environments you can use. I'm using one particular environment. This is the Octave GUI. You may be using others. Okay, let's see here. I was just trying to clean this out. I guess still not. Oh, I guess I'm still in the middle of a command. There we go. Okay, so is this readable? I guess that's fairly readable. Good. Okay, so let's do a little bit of practice here. What is this? It's an array. What's the dimension of the array? Because if you're going to talk, or it's an array, that's true, but it's also a matrix. So let's talk about it in sort of matrix form. So we have rows and columns. How many rows? How many columns? 1 by 4, right? 1 row, 1 column. Okay. All right. So how about what is? And it's an array of what? What type? Integers, right? Okay. So what is this here? It's 1 by 4, and what's the type? Okay, now in a MATLAB, they don't allow you to mix types. So what's going to happen here is it converts all the integers to floats. All right? So that would be an example there. How about this here? What's that? Okay, string is one thought. Anybody else have another thought? That's a reasonable guess. Okay. But everybody agrees it's 1 by 4. I don't think there's any debate by that. Okay. Well, actually, what is this in the error? Oh, that's interesting. It shouldn't have done that. That's very interesting. Let me do that again. Let me see what happens. I would have expected that to be an error. I wonder what it converted it to. It errors. Okay, so it should. Yeah. So this is another important point. And actually we make no apology for this. We give you a variety of environments to work in. There are differences. I mean, this is an example of how there are some differences to this. So if we did, let's see what it comes up with. Oh, that's fascinating. So we define, okay, so this is a great example of something, it just behaves wrong. Why is it that when I assign this sort of mixed vector to A, and then I look at what A is, it comes back with 1? That's very strange, right? Okay. Anyway, that you should not do mixed types in MATLAB I mean that just sounds wrong to me. Okay, so let's do some other things too. Now, since of course you can do what I was doing with spaces to separate the values in the array. You could do commas as well. That would be another thought. All right, so you could do that, and that should come up with the same thing. What happens when I separate it by a semicolon? What happens then? It's a 3 by 1. So semicolon is the limiter that will indicate that I'm going to do another column rather than row. And so now I have a different shape. And there is this operator called size, which will tell you these dimensions. Because basically, this is your type information or your data structure information in MATLAB is the shape of, we have to know the type, and then it's the shape of the matrix. So it tells you it's 3 by 1. Whereas if we look at, go back to, let's say this one. Let's see, where is it? Here's one. Yeah, if we do that and we do size of A, then we see it's, instead of 3 by 1, now it's 1 by 3. So anyway, those are important information. Now, the other thing that you could do is you can combine this together, obviously, and then make a matrix. Let's do a matrix mat. And let's say we can do 1 and 2, that's the first row, and 3 and 4, that's the second row, 5 and 6, that's the third row. And we're going to end up with something that is, what's the size of this? 3 by 2, exactly. So that's good. And it's the way we would have expected, right? So now, one of the things you typically are going to be doing a lot of in MATLAB is you're going to want to change something from one shape, 2 by 3 is a shape, to another shape. Okay, there's 6 elements there. Right? So, it could be that, for example, instead of having it be 3 rows and 2 columns, maybe you want it 2 rows and 3 columns. And that's very common. I mean, you're doing some sort of matrix manipulation, you've got the data in the wrong form. These kinds of data manipulation operations are really at the core of much of what people do with programming. You typically are doing, you've got data in one form, you're trying to put it into another form. So what I'd like to do, I'll tell you what I'd like to do. Let's call it, we'll call it other mat. Here's what I'd like to end up with. I'd like to end up with 1, 2, 3, 4, 5, 6. Okay? So that's what I'd like to end up with. And now I've got this thing right here, this first mat that's 1, 2, 3 in the next column, then 4, 5, 6. So one simple thought about this is that since these are matrices, the normal kinds of things that you do with matrices are available to you. So you can do a transpose. Everybody remember how transpose works? The rows becomes columns, the columns become rows. So for example, that mat over here, I can do a transpose. And the way you do this, I mean, if your work, let me show you the simple way, and then I'll explain why that's probably not the best way to do this, and then we'll do it probably the preferred way. So the simple way is you just, well actually let's do it, this will definitely work. I think this works also in MATLAB. If you say transpose of it, that will work. Okay, that's the transpose of it. And so what it did for Matt is it took the first column and made that the first row. So 1, 3, 5. So 1, 3, 5, and then the second column becomes the second row. So that did exactly what we expected. There's a shorthand way of doing this where you can do it with a prime, and that will produce the same result in this case. The caveat here is that technically what that's doing is it gives you the complex conjugates of the values. And so if you're using complex numbers, you don't want to do that. You would instead do probably something like you use the matrix operation, use a dot and a prime. I'll get back to the dot operator later on. In this case, for integers, it's not going to make a difference. But just be aware, the prime is so convenient to use that people do it a lot. Just be aware that if you're using complex numbers, there's some implications. Okay, so let's go back, and for right now, I'll use transpose just to make sure that it's very clear what we're doing. By the way, this is probably a great point to make as well. When you're using a programming language or anything, a toaster, you would like the natural thing you would think to do to be the right thing. I want to take the transpose. There should be a function called transpose. I want to take the inverse. There should be a function called inverse. And the set of these kinds of operations that are complete for the the kind of abstractions you're working with. In this case, our abstractions are matrices, and so our notions about what's natural for that come from linear algebra. What do we do with matrices? We add them, we multiply them, we take their inverse, we take their transpose. Those are the most common things that we're going to do with matrices. And so you would like to see that as you do this, as you work with matrices, the verbs that are available to you in MATLAB match that. This is true when you write your software too. You want to create abstractions that are natural for someone. And that means that the kind of thing they would expect to do from whatever domain they're coming from are there. So our domain right now is matrices. We just have these operations we're working with. Okay, so let's go back to this. So we've got transpose. Let's go back to the original problem. The original problem is that what I really want to get is this other mat. I've got 1, 2, 3, 4, 5, 6. Okay, 2 rows, 3 columns, and I know that I've got mat right now. I can take the transpose of it, and I will end up with 2 rows, 3 columns. But I don't have the right values in the right places. So now comes the question about how do I do that? This is a very common thing. How do I make it so that I get the right values in the right places? Any thoughts about that? What we might do? Could type it in again. Another thought. Okay, so what the problem is, if we go back to mat over here, okay, what the problem is the way that transpose works, it's working by columns. If instead, the way we would like to do this is if we want to go across instead, like that, we're going to have to manipulate it a little bit differently. And so typically the way you do this kind of thing is you try and you explore what's available to you with the various operations, or you have some predefined notion about what it is that you want to do. So here's something simple to try exploring. And that is that if you instead looked at, if you look at the transpose here, the transpose of mat, what's interesting about that is, okay, let's go back here and see how transpose works for mat. Okay, transpose for mat, what it did is the transpose of mat goes across the rows to produce the columns. So it goes across this row, 1, 2, that's 1 and 2. Then the next column is going to be 3 and 4. So what we would like to do is arrange things so that oh, I'm sorry, that's other mat. Here, it goes, let's see here. Let's get them together. Here's mat, and let's do, here we got them together. Okay, so the way it's going to work is if we've got the mat over here, it goes 1, 2, 3, and 1, 2. Okay, so it gives me 1, 2 for the column. Then it begins this for the next column. So another thought here is, and this is the kind of thing that you might play around with. If I said instead, if I did something instead like the transpose of the matrix, and then looked at what would happen as I did other transposes, or I took columns and looked at what I did with other columns, that would be another way to deal with this. So typically what you do is you try and explore. You either look for something from the domain that you're familiar with, like linear algebra, or you try it differently. So this would be a good exercise, and actually I'll put this in here in the notes, because this is available for recording. Find a sequence of MATLAB commands that make other mat from mat. So here's another point, is that the percent is a comment. So when I press enter here, nothing happens. So play with it. This is a good thing to sort of explore and see what it is that you can learn to understand. All right, let me go back to the presentation. And I'm going to skip over parts of this. The notes I look at, I will not necessarily rigorously follow the slides, because I will tend to do some of these interactive things. So there's the data structure stuff. We sort of gone through this. What are these data structures, giving this, for example, this one right here. What is this? How would you describe this as a MATLAB data structure? Okay, what's the shape? And what are the types? That's it. That's the way you describe it. The matrix shape and the types. Okay. So, all right. And then this one right here, what's this going to be? Any thoughts? It's going to be an error. Right. Because MATLAB only allows you to have regular shapes. They have to be complete matrices. Okay. All right. Fine. All right, so I'm not going to go through all this. These are in the notes. Okay, so let's move on to built-in functions. So we've seen a little bit of built-in functions already, because we looked at transpose, for example. MATLAB has a lot of built-in functions, and typically the built-in functions, these are not things that you would go through and rigorously present. more what you're looking for is how are built-in functions organized. So when you're programming something, you want to do something, you can figure out where to look. I mean, after you've worked with a few programming languages, it becomes sort of obvious. Actually, just your spreadsheet experience is probably enough. Think about how the functions are organized in spreadsheets. You've got, some kind of math functions. There's some statistical ones. There are string manipulation. There's addressing. I mean, this is what you're looking for. How are they structured? This is a common way that things are structured, depending on the domain. So there's some sort of arithmetic functions. There's some things that are specific to matrices. We saw when we were looking at the spreadsheet, we had Booleans that we came up with. We were doing ifs, so there's some relational, and there's stuff much more. You can look at that. So, I mean, the usual suspects for arithmetic functions. You can do something like a modulo if you're trying to see if one number divides another number. So, for example, here, the way this works is 7 is the number you're trying to test, and does it divide? Basically, you're looking at what the remainder is after you divide by 3, and so the remainder is 1. If we were looking at 6, what would the remainder be? 0, and that means that 3 divides 6. So, okay, so then you've got, and then the other example here, these are other, I grouped them as arithmetic functions. You could look at them as data analysis or statistical functions. You can do the usual kinds of things if you have some data. You can look at the minimum, the maximum, the mean, and standard deviation. Needless to say, that's very useful for data analysis. Okay. The other thing I just mentioned in here, which I think was sort of obvious to you already, is the notion of an assignment statement. I've done that already, and this brings up the notion of variables. Again, I think you're probably familiar with this already, and that is a variable is really just a container, or you can view it as a pointer to a set of other values. And so I could have the same name actually have many different meanings. I could assign, and I did that before in the demo. I would assign A to a 1×3 vector, or A to a 3×1, or something else. And depending on what I assigned it to, A has a different structure, a different shape, and potentially even different types. All right. The other thing about MATLAB is you may be less used to this, or maybe you are, is case matters. If you type in something in lowercase, that's different from something in uppercase, or mixed case. Most of the commands are in lowercase, so you have to be aware of that. All right, so let's go on to matrices a bit. And this is really a variation on what I showed you before, maybe give you some hints about how to approach some of this. Suppose you conducted some experiments, and actually let's do this with the code. Yeah. There we go. All right, so suppose I did an experiment, and let's see. So here's my data. I've got a 1, 2, 3, 4, 5, 6. I'm just putting in some numbers. Okay, so that's my experiment. It turns out, actually, to make this more interesting, let's make it so that it's more apparent that these are different experiments. So 1, 2, 3, and then 10, 20, 30. Okay, so there are 2 experiments that were done. The first 3 values are from one experiment. The second 3 values are from a second experiment. And now what I would like to do is this is sort of an awkward way for me to manipulate the data. I mean, for example, remember that function that took the means and the standard deviations? I probably want to have this structured in a way, a more useful way, or I'll call this useful data, would probably be something like 1, 2, 3, and then 10, 20, 30. That's probably more useful. Because now what I can do is I could look at maybe the mean values of each column, something like that. Actually, yeah, if I look at, let's see. I think that's the way this works. This is the other thing, is you sometimes just sort of look at what the values are. Yeah, that's exactly the way it works. So mean of useful data gives me the mean value of each column. So that's nice. I didn't have to figure it out otherwise. But I want to get from data to useful data. So this, again, very common. So how are we going to do this? There is this built-in command. This is an example of a sort of a data manipulation built-in called reshape. And it takes as the first argument the data you're looking at, and the second argument, and the remaining arguments are the shape that you want. So we want 2 rows and 3 columns. I think that'll do it right. and that did it wrong. Okay, that's very interesting. Okay, so now the question is, what do we do to get it right? So the reason why it did it wrong, what it's doing is, the way it's reshaping is it's taking this value first and then that value and then making it into a column. Okay, and so what we would like to do is we're going to want to structure it a bit differently. We want to make it so that it goes, that it takes these first three values and makes it into a column. So what we could do here, which is an interesting way to look at this a bit differently, is if we take the data and suppose, now this is not what we want, but it's getting us closer in a way. See, what that did is we're working, what reshape does is going to first work with the columns. Now at least we've grouped together in that column the data that we want together. That first column is experiment 1. And that second column is experiment 2. Okay, now we've got a simpler problem. We want to move from this structure to the row structure, where the first column becomes the first row and the second column becomes the second row. And what's the MATLAB built-in function that lets us do that? Yeah, the transpose. Transpose. So what we'll do is we'll say transpose of reshape of data 3, 2. And this is the kind of thing that you'll want to do. And this is very common, the way you sort of built up incrementally. Remember Dave's lecture about the command line tools and this notion of piecing together small tools to make bigger tools? This is a great example of that, and this is the kind of thing you do. And then also, it's all about the domain that you're working in. So we're working in the domain of matrices. What do you have in matrices? Well, you have this ability to sort of morph a sequence of numbers into rows and columns. Okay, and so that's what reshape does. But then you've got transpose, which will allow you to swap rows and columns. So this is the way you do your data manipulation. All right, let me go back to the presentation. So that is really this whole discussion over here, the matrix manipulation, and it will go through and show you, oh yes, we shaped it wrong, and so then we can eventually get it right. I use slightly different numbers, but the concept is the same. All right. So let me go back to summary there and show you one other thing here, which is very useful. Okay, so again, matrices are a primary way that we're working with things. So the natural question is, well, how do we reference elements in the matrix? So let's go back to data over here. Actually, let's call data. We'll do data this. Let me just grab that. And what I'd like to do is, this is a more interesting form for it, and I'll call this data. Well, this is we'll yeah, I'll just call I'll call this mat. This will be my new mat, and this will be this. Okay. All right. So that's my matrix. So now I've got, what shape do I have there? What's the shape for mat? 2 by 3. Right. Okay. So now I want to pick out individual terms in that. So it works, and this is another example of something which is a good API, or it's natural. So how do I reference the value 10 in this matrix? Well, where is it in the matrix? What row, what column? It's row 2, column 1. Okay, so if I want to reference that, I'll do it basically just like you would do it if you were doing linear algebra. Row 2, column 1. Okay? And that's very useful. Now, the other thing you want to do is sometimes you want to pick up an entire row. So suppose, because that's, the first row is my first experiment. So how do I pick up that entire row? Has anybody done this kind of thing before? Okay. So if you want to pick up an entire row, you know that the first value there, which is the rows, has to be 1, because that's the row I want. But you don't want to, and technically, I mean, you want, like a star or wildcard or something for the column, because you don't want to limit yourself to one column. And in MATLAB, the way that works is it's this colon, and that gets me the whole thing. Now, the reason why that works, that colon operator is actually really critical to the way a MATLAB operates. I mean, some very powerful things you can do. Colon indicates a sequence. So for example, if I wanted to print out the numbers, let's say 10 to 15, I could just do this. And that's really, really handy. So when you put a colon in there, what that's telling you is, just pick out everything in a range, however long that range is, if you don't specify. But if I'd done it a little bit differently, if I'd said mat 1, and I just wanted the first two values, well, I could write them down differently. I could do this. And if I was working, let's do it more interesting. Let's say I'm doing the second row. Now make it a little bit more interesting here. So now I should come up with 10 and 20. Oops. Okay, so that gives me the range. And what it's doing is it's substituting in for the second argument. It's the same thing as, mat 2, 1 and mat 2, 2. Okay, and so this is another thing you will find over and over again in different languages. The way you address things will vary. So do you remember what we did in spreadsheets, which was really important in terms of addressing? How did we address things? We addressed them in terms of actually rows and columns. We just had, or it's columns and rows, where the letters were the columns and numbers were the rows. And remember what we did if we wanted to range? Let's say, we wanted, column A and rows 1 through 3. We'd go A1 colon A3. Right, so in some ways, it's very similar to what MATLAB is doing. So it's actually not too different from what you're already used to. And so this way, you can actually do this on both of them. I mean, I don't have a very big matrix here, but we can do it differently. But we'll get back to that in just a second. Another thing you're going to want to do is you're going to want to build up things incrementally. So suppose I have this vector v, and that's 1, 2, and I'm doing some computation, and I'm saying, you know what? Whatever v is, I'm in the middle of doing some repetitive computation. I'm doing a loop of some sort. What I would like to do is add something else to it. Maybe I want to add a 3 to that vector v. Right now, it's the shape of it is what? It's 1 row, 2 columns. Okay. I want to add a 3 on there, so it'll be one row, 3 columns. And the way you do that is you just say v is equal to v, the way it is right now, and then add a 3. And if you look at the size of this, it just says it's 1, 3. And this is another example when we're doing, we're producing answers through iteration. We're going to want to be able to do this. We're going to want to be able to add more values in, because that's parts of our answer. So, and you can do this in bigger ways too. So let's see, we've got mat over here. Suppose we did, well, what will this be? Any thoughts about what we're going to end up with? How about if I show it like this? A little bit easier? So what we've done is, and this is where the abstractions become a little bit more interesting. Before, we were adding things on where there are individual scalars. But there's no reason why we can't actually add, append matrices to another matrix. What we've done is we've taken a block or a matrix of size 2, 2, 3, so 2 rows, 3 columns, and we've appended behind it another matrix of shape 2, 3. So we end up with how many columns? 6 and 2 rows. Okay, all right. Now that you've got onto this, how about this? What's going to happen here? Yeah, so what's going to be the shape? 4, 3, exactly. This is the way, with any programming language, you want to find out the natural kinds of representation. So all we're doing here, and this is sort of the basic concept behind MATLAB, and it's very analogous to working with spreadsheets. You've got some shape of numbers or strings or anything that you want to work with. And what you're doing with it is you're changing those shapes, morphing them in different ways. You're adding to them. You're picking out some subset of them. So let's take this. Let's call this Big Mat. Okay, and that's going to be mat. Okay, so let's play with this a little bit. Suppose I want to get a part of this. Actually, you know what? Let's do this as I'll do it a little bit bigger still. Yeah, actually, let's make this even more interesting. Okay, so we're going to do this. You can multiply as you're doing this. Okay. Okay, and so what am I going to end up with as a shape? How many rows? Well, I've got 3 matrices that are all what? Each one of those matrices is 2 by 3. Okay? So the rows, right, so 6 rows because I'm stacking them one on top of each other, and how many columns? 3. Exactly. Okay, so this is what I got, and you can see what happened here. I mean, they got multiplied as they went along. Okay, so now what I'd like to do, sort of a challenge for you to sort of think this through. You see this, so this is the this section right over here. See if I can highlight it, see if this will work. It doesn't work quite the way I want it to, but I'm trying to pick out 20, 30, 200, 300. That's what I'd like to pick out. And this gets back to this notion of addressing. How do you address that? Well, you're familiar with spreadsheets. Think of this just as spreadsheets, right? So this is column A, B, C, and rows 1 through 6. It's just that, you know, we're going to call it differently. We're going to call this, you know, columns 1, 2, 3, and rows 1 through 6. So just a slightly different naming. So what row and column is the 20 there? What row is it? 3, right? I'm sorry, the second 20. There are 2 20s there. I apologize. Right, the second 20. The second 20 is row 3, okay? And then this row right here, where the 300 is row what? 4, right? Okay. And I've got column 2 here and column 3 over here. So what I want is for Big Mat, I want to go from I'd like to have rows 2 and 3. So 2, 3, and I'd like to have which columns? Okay, right, so yeah, columns, so it's this column here where the 30 is, and this column here where the 300 is. So what row is this? Or I'm sorry, what, oh, okay. I've sort of mixed people up here. So that the column, right, I apologize. Yes, it's columns 2, 3. I apologize. Yes. Okay, let me make sure we get this straight because I want you guys to be confused. We picked up columns, rows 2 and 3 here. That's where this 20 is and this 200. And we want columns 2 and 3. And so what will I type in for the column range? 2, 3. Right? Okay? And so then what I picked up here is the wrong thing. Why did I pick up the wrong thing? What did I do? What did I do wrong? Okay, I mean, because this is pretty common, this kind of mistake is pretty common. Okay, let me type it in again. What should I have done differently? Okay, I got 20, 30, 20, 30. So I obviously picked up this over here. Okay, so what row is, and I want to pick up 20, 200, 30, 300. So what should I have entered instead? What are the rows? Just count them. This is row 1, 2, 3. This is row 4. So I want row 3 and I want row 4. So 3, 4 and 2, 3. Okay? It's no more complicated than a spreadsheet. Just the way we're calling the columns numbers rather than letters. That's the only difference. Okay? Does that make sense? This is the primary way you're going to do manipulation in MATLAB. Okay, so let's go back to the presentation. Okay, so string manipulation, you do strings too, pick them out. Okay, I'm not going to go through that. Relational, so this is a little bit different, although not terribly so. You can do tests for equality or inequality. So the you just have to know what the symbols are. This varies with different languages. So in in MATLAB, if you want to say is one number equal to another, and you want to create a Boolean, it's going to be either true or false, use a double equals. So 1 equal equal 1 is true. 1 equal equal 2 is false. So, you know, true is 1 and false is 0. And then the less than greater than. And then when I assign a b over there, to b is equal to the result of is 2 greater than 1. Okay, so b is true and b is a Boolean. That makes sense? Okay, so this is really the extent of the data types. Generally speaking, the hardest part of a language is to understand its data structures, its data types and data structures. MATLAB is relatively easy. When you think about it, you take a step backwards, it's all about matrices. There are these basic types, string, float, bool, integer, and then you can arrange them into any shaped matrix that you want, where you specify rows and columns. That's it. And then you can manipulate that. You can select out regions with ranges. You can, you know, do columns. You can reshape it. That's all you got. So it's relatively easy. Okay, so the rest of what I'm going to talk about today on conditionals and looping, these are things that you will find in every single procedural language. I mean, there are non-procedural languages like SQL that we'll get into later. But if you're, you know, you work with Python, as we will, C++, Java, JavaScript, they all have these constructs. They slightly different syntax, but it's all the same. The data structures are the main things that vary. Okay, so I'm going to have this running example here with prime numbers. And I've got a number here, 3. And so I've got this variable I'm going to create. And the sort of squiggle over here, squiggle then equals, that's the way MATLAB says not equal. So when I say is mod, so mod is for modulus, when I divide it by 2, if it's not equal to 0, so what I'm saying here is 3 here, will it divide by 2? No, because the answer is not going to, the mod of this is not going to be 0. So if it's not equal to 0, then I'm saying is prime will have what value? Right, so is prime, right, so if it's not equal to 0, well, first of all, will the result of this, what will be the result of mod of div comma 2 or 3 comma 2? This will be a 1, right, because, you know, 3 divided by 2 is 1, the mod of that. So that's not equal to 0, so that's true. So then is prime will be true. Does that make sense? This is very common kind of logic that you will see in programming. And you take it apart, and the way to analyze this, because it's, you know, it always takes some time to work your way through it. The way to analyze this is do it piece by piece. You know, do each step of the computation. You know that the answer here is going to be 1. And so you know what this operator is. This is the not equal. So, you know, is, you know, 1 not equal 0, is that true? That's true. So is prime must be true. And this is a Boolean. Okay, so here's the way a conditional works. So conditionals, you know, surprise, surprise, if. We've seen if before in a spreadsheet. It's used a slightly different way. It's used sort of computationally. But we're going to use it in terms of the way we execute code, the sequence of statements that get executed. So what this says is, if it's true, if is prime is true, and from the statement up here, is prime will be true, then I'm going to print out, and disp is a way of printing out, yes. Okay, and if you have an if statement, it's paired with an end. Okay, and that's probably, at this point you've probably got, you've got 50% of if, there's an else, you're going to learn in a second. But this is 50, and this is also the way it's going to work in almost every single language you encounter. Yeah?
Is there a difference between octave and MATLAB? Is that quotes for string or double?
Yeah, you know, there may be a variation. Is that true? I thought that you could use double quotes, but you have to use them consistently in MATLAB. I don't know the answer. Do you know the answer to that? Okay, all right. So it may be that, and I will watch myself on that. Okay, yeah, so if those of you who are using MATLAB, you may need to use just single quotes. All right. And these are the things that can drive people crazy with little differences between languages. So, but I also, again, I make no apologies because I think this is an important thing to learn. And where you have to be aware of little differences. For example, it turns out that in octave, instead of the squiggle, you could use an exclamation mark. You can say exclamation equals, and that will be equivalent. Some languages will do that for knots. That works in octave. It doesn't work in MATLAB. Okay. All right, and this is the if statement, and then the output of it is yes, because it is fact prime. Okay. All right. So the other thing that we're getting to right now, which is very useful, I'll make reference, and this is something you have to be aware of in any programming language, the notion of a statement and a block. And they're two slightly different concepts. So a statement is generally a single line, although you can have long lines with continuation. But generally, you think of this like a single line. It could be an assignment, like div equals 17, or is prime, or even this single line here, if is prime. That's a statement. Okay. The difference between a statement and a block is some sort of logical grouping. And generally, we'll talk about two kinds of blocks. We'll talk about if blocks and then for blocks. For blocks are going to be for loops. And the reason why you talk about a block is there's usually something special that happens inside of that block. For example, it may be that certain variables are defined only inside the block, not outside of the block. And that will be important. So this is an important conceptual thing, statement versus block. All right, so let's go back to the prime number example. Okay, so here, let's see if we can sort of reason our way through this code. So there's an assignment here that div equals 4. And again, we're computing the same Boolean over here, is prime. And then we've got the if statement. And what will be the output of this small sequence of code? Okay, and why won't it?
Because is prime is divisible by 2.
Okay.
And it fills the check at the very top where it says it's not equal to 0.
Right. So this if over here, if is only the code that within the if block. You only execute the if block if the argument of the if is true, and you're saying that is prime is false because 4 is divisible by 2. That makes sense to everybody? This is the kind of thing you'll go through a lot. You'll try and reason your way through it. And so yes, in fact, there's nothing out there. And you already answered the reason why no output. So that's great. Now, this is probably not the way in general we want our code to work. If it's prime, we want it to say it's prime. But if it's not prime, we want to say that it isn't prime. So we've got to figure out a way to fix this. So this is where the else becomes handy. So if it is prime, then we're going to print out yes. Otherwise, we'll print out no. And so this is an example of an if-else block. So we have an if here, and there's statements, one or more statements there, and an else here, and one or more statements there. And that's really, there's some other minor variations on this, but for the most part, this is the main thing you have to know about conditionals. And what you've done is you've changed what's called the flow of control, the sequence of statements that execute. So in this case, if is prime is true, then you would say go here, and if it's not, then you go here. In this case, it's not, and that's what it is. What we execute over there. Okay, let me pause for a second and see if there are any other questions about if statements, conditionals. This is really the essential of what you need to know, and then you need to play with it and get a feeling for it. Because the hard part is not the concept. The hard part is sort of puzzling through, okay, I've got these negatives. Okay, I've got this, this modulus here that's not equal to 0. What does that make this over here? And then what does that mean this is here? So I know which statement is actually going to execute. That's usually where it gets more involved. It's the logic behind it. Okay? All right. All right, so that's one core concept. You'll see in almost in all procedural programming languages a conditional. The next one, which is a core concept, is iteration. This is something we really couldn't do easily with spreadsheets. Remember the way we would do iteration in spreadsheets if we wanted to go from we did the problem in class with a sequence translation. And if we wanted to make a larger sequence, then what we had to do is we had to copy more rows in the spreadsheet so that it could do the analysis, because it actually had to list out every single one. And that's a very inconvenient way to do it, especially if you have a genome of many, 3 billion, nucleotides. This is not a very, containable problem. Okay, so let's give some examples here. So what we're going to do is we've been working with prime numbers. Okay, so now we're going to work with larger prime numbers. So let's, larger numbers. So now, we're going to advance the state of the art here. We're going to go from looking at, 2 and 3, we're going to go up to 8. We're getting close to double digits here with prime numbers. Okay, so if we want to test that 8 is prime, we want to see, well, does 2 divide it? Does 3 divide it? Why do we only have to look at 2 and 3? Any thoughts about that? Remember, with prime numbers, it means that it's only divisible by 1 and itself. Okay, so that means that you only have to look at numbers up to the square root of that number. So the square root of 8 is a little less than 3. So we don't have to look further than 3. And so that's why these two numbers are enough to look at it. So let's talk about this logic over here. So this is that same variable is prime. Okay, and so it's going to be prime if it's not divisible by either 2 or 3. Or okay, so that means it's not divisible by 2 and it's not divisible by 3. So this test over here, where it says mod div 2, 3 not equal to 0, that says not divisible by 2. And this says not divisible by 3. And the double ampersand here means both of those are combined together like a logical and like a truth table. So you'll see that again. That's the way the logic works. And so that's this answer why it's only divisible there. Okay, so that's our is prime. And then we use exactly the same logic we had before. If it is prime, then if is prime is true, we print out a yes. If it's false, we print out a no. Okay, so really the innovation we had here was a larger number, we had to have a more complicated test. That's what happened. That makes sense so far? Okay, so that's our no. Okay, so how about if it's larger still? Okay, let's get into double digits. Well, it becomes more and more inconvenient. I mean, we can get this optimization by only looking at the numbers, a fraction of the prime numbers. We can, in this case here, I went up to 4. Let's see, technically I should have gone up higher than that. I should have gone to 5. Okay, that's interesting. But you can see what happens as you go further. Then you have to have more and more of these tests. By the way, the 3 dots over here are MATLAB's way of continuing a line, because this is getting to be a fairly long line. So what it's saying is, I'm not divisible by 2, I'm not divisible by 3, I'm not divisible by 4. I should also have here not divisible by 5, because the square root of 17 is larger than 4. And so, okay, but then you can see what's happening here is it gets more and more inconvenient as we go along. So we've got the same logic down here in terms of how we treat the value is prime, but we've got more and more ampersands here. And if we go further still, suppose the number is several thousand, then it gets to be very inconvenient. 2, 3, 4. A lot more. Finally, 48. 48 is the square root of 2303. So, obviously this doesn't work very well. It scales poorly. By the way, if we're doing this in a spreadsheet, we would do exactly this thing of basically copying those lines down one by one. And that's essentially what you did in your or doing in your homework. You're essentially producing each one of these lines because you don't have the ability to iterate. Well, fortunately in MATLAB you can iterate, and so let's go on to that. This gets really boring. So there's this notion of a for statement. And let's take that apart. So what we've got here, and describe what it's doing over here. So max divisor, all I'm doing here is just saying what's the upper bound I have to test for. So I've got to look at all the numbers up to the square root of the number I'm testing. Okay? I don't have to go further than that, because if it's larger than that, if a number larger than the square root of the number I'm testing, it would have to have another factor that was less than the square root, which would mean I would have already tested it. So I'm okay if I just do that. here's the for loop. So what for says is, essentially, we're going to expand out what you just saw before, and we're going to do this range. So you remember the colon from before? This is a range. It says go from 2 to the, whatever this thing is, the maximum divisor I have to test. And then it has this logic here to see, well, if it divides, so this statement right here says, do I divide by n? If it's, is it equal to 0? If it is, then I'm not a prime. Okay? And so when I do it with 15, what's going to happen is, at what point in this, well, first of all, 15, what would be the number I would go up to? How many numbers would I test? What would be the upper limit of, what's the square root of 15? Yeah, it's a little bit less than 4, and so you take the ceiling of that, that's going to be 4, and so I probably would go from, probably max divisor is going to be 4. So I go from 2 to 4, and then I test for 2, 3, 4. Does this test hold? So what's going to happen with 2? What will this be? Well, does 2 divide 15? No. How about 3? 3 divides 15, and so it will ultimately, it will print out a no. Okay. So that's the way this for block works. And then inside, there's you see that we have 2 blocks here, which is worthwhile to point out. A lot of times you may have many nested blocks. You've got this outer block that's a for and an inner block that's an if. Okay. All right. So the problem is that there's actually an issue with this code. We've seen this issue before. Okay? So it's great for finding numbers that aren't primes. When does it find a number that is a prime? What does it do? It doesn't do anything. There's a, you've probably run into people many times who can only say no, never say yes. That's what you've got. This is their code, right? It can only say no, it can never say yes. Okay, so we've got to fix it. All right. Any thoughts about how you might fix it? Well, you could, yeah, there's probably an else in there too. I mean, it's a little bit tricky. You've got to deal with the loop because it's not just, it's got to be an else only. You've got to make sure that it doesn't divide anything. I mean, it might not divide, one number, but it might divide another. So you've got to remember that. So it's and this is part of the challenge with designing loops, is trying to figure out what the right logic is. Okay, so here's an example of something that could do that, but the else idea is certainly there. Here's one way to do it. Let's assume that the answer is that it is prime. And the way you become prime is that you never enter into one of these loops, to the if block. If you never get into the if block, then that means you've not divided anything. So what happens is, the way we've modified the previous code is you assume that it's prime, and then here is where instead of just printing out no, it's not prime, what we do is we just store that as the answer, and then at the end we display the answer. And so the answer is going to be no if there's at least one case where it is divisible, and the answer is going to be yes if there's never a case that's divisible. That logic is very common in loops. You're basically, when you think about it, the abstraction is you're searching to see, is there at least one, or is there never one? I mean, that's the kind of logic that goes on here. Okay. All right, so that's the way we expand it. Okay, so one of the things in terms of being able to sort of analyze code is this notion of trying to sort of expand it, especially with loops. Loops are very compact representation of something. And from a spreadsheet very graphically that since we didn't have loops, we basically had to make rows for each step in the iteration. And so if there was a problem, for example, there may be one iteration where we're doing something silly, like we're dividing by 0. You see that very dramatically in a spreadsheet kind of representation because you would get some sort of type error. In a loop, it's all hidden, right? Because we've got this very compact representation. It just says 4. And you've got some loop range. So one of the things that you want to do, or have the capability to do, is basically to break out the steps in the loop. So for example, over here, this loop here, where we're going from 2 to 4, it has this block here that's repeated, this if. And what we're doing essentially is we're breaking it out into separate sequential steps where, in one step, the value of n is changing each one. So here it's 2, here it's 3, and here it's 4. And if you encounter a problem in a loop, typically what you're doing is you're trying to figure out which value of the loop variable did the problem arise with. And that's a typical kind of analysis. The other thing that we've got here, and I haven't spoken about it explicitly, remember before when I talked about blocks, and I said that one of the things why blocks a lot of times are important is there's sometimes something special that goes on inside a block. In this case, for a for block, the special thing is that the loop variable is defined. So the loop variable here is n. That's a thing at the top. So it says for n equals 2 to 3, or 2 to 4. So n is the loop variable. And that means n is defined in here. N is not defined outside, and when you get outside the loop block. I mean, you can't count on it. Sometimes sometimes some programming languages will define it as 1 plus the last value. But in general, it's very bad practice to count on the loop variable being defined outside of the block. So you've got this loop variable, it's defined inside the block, and one of the things you want to do sometimes is if you get an error when you're running a loop, you want to figure out what was the value of n for which you had that error. And it's both, so in this case, a loop is both an advantage to you because it's a very compact representation, easy to understand. On the other hand, it's a disadvantage because it is so compact, a lot of times you have to expand it out to the sequential equivalent to understand what it is and where something went wrong. Okay. All right. So the procedural languages, basically, covered the essentials of it. The things that I have not covered, and I imagine, how many of you have written loops before in your MATLAB code? So about a third. So for most of you, I think this is somewhat new, and my guess is some of the analysis of this is a little bit different. So what you've got right now is sort of the basics of writing a script. Something that would repeat, a workflow that you've had right there. What we haven't talked about today, and we will talk on Friday, are functions. And functions provide, really, these become then the building blocks for building much more complicated software. So we've got data types, data structures, which I almost combined together. The built-in functions, the main thing there is, the natural kinds of things that you want to do should be available. And you just have to figure out where they are and what the structure is of it. I mean, for example, with the mod function or modulus, I always forget which is the dividend, which is the divisor. It's easy to switch them around. You do one or two tests, you figure it out. But that's the kind of thing that obviously it's important to figure out. And then the flow control concepts, with conditionals and iteration. And for many of you, this may be the first time you've encountered that. Okay, let me pause for a second, then I'll talk about the homework. Any questions at this point? We've actually gone through a reasonable amount of material. And the other thing is, I think, conceptually, there's a lot of new things here, I think, for people. And so that takes a moment or two to digest. Okay, all right. Yes?
MATLAB, they have like the cell type, which is what strings usually, if you have an array of strings.
Yeah, right.
That's a cell type. And then you can also add numbers into like cell types.
So are you talking about cells in MATLAB, or are you talking about cells in spreadsheets?
It's a type of array.
Oh, okay. Yeah, MATLAB has some extended data structures where they've tried to organize things to provide more complexity. I'm not going to go there. I mean, but these are the kinds of things. So MATLAB, needless to say, just having matrices has its limitations, and modern programming languages have much more complexity associated with them. And I think that's what you were talking about, is some of these more extensive features in MATLAB. Other questions? Okay, let's talk about the homework a little bit. Okay, so the usual thing, homework will be, it's assigned today, Monday. It will be due in a week, so a week today, Monday at midnight. And so that gives you, 2 more. Oh, I'm sorry, Wednesday, I'm sorry. I don't know what day of the week I'm in. Thank you. That explains all the confused and worried looks. Okay, Wednesday, today, Wednesday, thank you, Dave. Okay, a week from today, Wednesday, at midnight. So that gives you, another the Friday class, the Wednesday class, and then office hours for the three of us. So hopefully it shouldn't be an issue. Okay, so what you're going to do is, and this is sort of thematic for the kinds of things we do. Generally, our homeworks will pick up on something we presented in class, and you extend it a little bit. So I showed you a little bit about finding prime numbers, how you could test for a specific number. And now we're going to test for you're going to find the first n prime numbers. Very analogous to the kind of thing that was done in the spreadsheet. And so the other thing I was going to mention is there are 25 students in the class. There are going to be 20 homework assignments. So it's going to be really helpful to us if you name things and structure things in a consistent way. It'll just allow us to do some automation to be able to test things. So we'd like you to do, each one of you should have your repos set up. You're going to create a folder for the homework called homework n, so homework 3 would be, n is 3 then. And then within that, it'll be very common. You'll have one or more file that gets executed. Now we're doing, MATLAB, so it's a .m file. That's the way it gets executed. And in this case, there's just going to be one file. The homework on Friday, I think you're going to have 3 files or 4 files, depending on how you structure it. But the main file, whatever that main file is that needs to run, call that the same thing as the homework. So homework3.m. If you could do that, then that allows us, poor Kenneth in the background who's going to be taking the lead at checking this stuff. There's some fairly easy scripts that he can write, and to be able to go through your codes fairly quickly, and that will help us a lot. Okay. The standard way we do the site, see if I can find the website quickly. Let's see here. Get to the website. So there is a homework link right here. And what that does is it takes you to a Google Docs folder, and you will see the homework. So the doc here is the homework assignment written out. And very straightforward. And then typically there's some kind of a discussion question. So, it should be literate though. I actually have one of my lectures is going to be on literate programming, and hopefully I do better on literate programming than literate English. Okay. Okay, and so that's another thing that a useful technique for you to know is that you have that link directly. And then also, hopefully people have been using the syllabus a bit. Put this big so it's better readable. And what you'll find is, for example, today's lecture, MATLAB Basics, it will link directly to the slides, so you have the slides available to you too. I think what it'll do is also put a link into the video once we get the video posted as an MP4. Okay, I think class is going to be over very fast because my battery is just about gone. Any other questions at this point? The class on Friday, I will warn you in advance, we're going to take things up a notch because there will be a science part to this too. I think only a fraction of you have taken biochemistry, is that right? Yeah? Okay, fine. So there's a little bit of biochemistry background. So Michaelis-Menten enzyme kinetics, if that is familiar to you. I'm not expecting you to already know it, but it will be, things will go through fairly quickly. And what I think you'll enjoy about the class is instead of being just about programming, and today was really just about programming. You didn't have to be biologists. I mean, you could have been mechanical engineers. You could have been political scientists. It really wouldn't have mattered today. But on Friday, it will matter. And the reason is that the class will instead of taking the focus of here are programming concepts, it will take the focus from here are data that you want to analyze. A reaction was run in your lab. You got this data out. We're going to use Michaelis-Menten kinetics to analyze these data. And the punchline, the end result is you have fit these data based on that model. And the data are actually taken from a scientific paper so that you can look at the paper. So I think in that sense, you'll find it very stimulating. But please attend because I think we will post the videos, but I think it will be important for you to be there in class. Okay. Any other questions? If no other questions, I'll give you a couple minutes head start. All right. Thanks.